bathtub fills evenly. Every edge rises at the same moment by the same amount. The Greenland ice sheet is more than a mile deep. Melted, and for about 1,000 miles around it, the sea falls, not rising more slowly, falling. 2 satellites called GRACE have tracked the Earth's gravity field since 2002. Worked out from that data, the sea is falling around a rapidly melting Greenland, and rising at coastlines far enough away. Which means the map of who floods is not the map most of us are carrying. Start with that map. Greenland melts. The meltwater ends up in the ocean holds more water than it did, and every coastline on Earth goes up by the same amount. It is not a foolish model. It is close to how the headline number gets built. If Greenland melted entirely, global average sea level would rise by about 23 feet. And that phrase, global average, is doing more work than it looks. An average is the height you get if you share that water out evenly across every ocean. The ocean does not sit still and wait to be filled. It has been pulled on for a very long time by the thing that is about to disappear. So how does adding water lower the water? 3 things matter here, and only 3. The ice is mass, an enormous amount of it standing in one place. The ocean is one connected surface wrapped around the whole planet. The rock sits underneath both. Everything with mass pulls on everything else with mass. The ice pulls on the sea pulls back on the ice. The rock pulls on both. That much ice standing in one place pulls the nearby ocean toward itself. And the ocean has answered. The sea beside Greenland is heaped up against that coast. The pull of the ice drew it there and holds it there. Now melt the ice. The mass goes. The pull holding the heap in place weakens, and the heap relaxes. Nothing carries the water away from Greenland. There is no current. The sea surface settles into the shape the weaker pull allows. That shape is lower along the coast the ice used to stand on. So where does the falling stop and the rising begin? Further out than you would guess. And where it stops, nothing happens at all. Walk out from Greenland. For roughly the first 1,000 miles, the sea is lower than it was. The fall gets smaller the further you go. Somewhere around the distance from Greenland to Scotland, it runs out. There, the fall and the added meltwater cancel exactly. The sea does not move. Past that line, the balance tips. Now the sea is higher than it was. Out here, the rise is bigger than the 23 feet, and it keeps growing the further out you go. This is not sea level rise turning out to be smaller. It is the same water, sorted by distance from the ice. So that is a shape, a fall, a line where nothing moves, then a rise that grows with every mile. That shape belongs to Greenland. Every other ice sheet writes a different one. The people who work on this call it a fingerprint, and the sea is not the only thing that moves. The ground is moving too. The ice was never only sitting on the rock, it was pressing on it. Take that weight off and the rock underneath lifts back up. It lifts slowly and keeps lifting long after the ice has gone. That is a separate mechanism from the pull on the sea, and it runs on its own clock. So a coastline near vanished ice moves away from the water twice over. The sea settles lower, the rock lifts. Then there is a third thing, and it is the one that sounds like a mistake. How the planet spins is part of what decides where the ocean sits on it. That is true right now, before any ice melts. Move enough mass from one place to another, and the spin shifts. When the spin shifts, the water sits somewhere slightly different. That does not happen only near the ice. It happens everywhere at once. If every ice sheet writes its own fingerprint, which fingerprint are we standing in? Not the one you would pick. Melt Greenland and the sea falls out to that 1,000-mile line and rises hardest furthest away. Melt West Antarctica and that map turns inside out. The fall is around Antarctica now. and the highest rise anywhere on Earth lands offshore of Washington, D.C. The IPCC's fourth assessment report put that collapse at about 5 meters, reached the same way the 23 feet was, by sharing the water out evenly. And for the coastline on the far side of the planet from that ice, sharing it out evenly is an undercount. In 2022, a Harvard-led team reported the first definitive detection of these fingerprints using melt from Greenland. The physics was not in question. Existing projections and much coastal planning were already built on it. What was hard was seeing it. Tides and currents and wind move the sea far more than this does. The work was to find movements measured in millimeters and prove they belong to ice thousands of miles away. I had this wrong for years, and I had it wrong with confidence. Sea level rise is not a bath filling. It is a redistribution. Which ice melts matters more than how much of it melts, and the ice that most threatens the American East Coast is standing at the opposite end of the planet. Every edge rising at the same moment by the same amount. The sea has never once done that.